When the ocean rises, the city falls silent. In just a few hours, streets turn into rivers, cars float, lights flicker, and the sound of the wind is replaced by the sound of water. This is not science fiction. This is what happens when a storm surge, one of nature's most powerful coastal forces, meets human infrastructure. Today, we explore what really happens when an entire city faces the surge. A storm surge is a rapid and temporary rise in sea level. It's caused primarily by strong winds pushing ocean water toward the shore during intense storms, especially tropical cyclones and hurricanes. Unlike a tsunami, which is triggered by undersea earthquakes, a storm surge is wind-driven, but its impact can be just as devastating. During a hurricane, wind speeds can exceed 200 kilometers per hour. As these winds rotate around the storm center, they force massive volumes of water toward land. When this water has nowhere to go, it floods everything in its path. Homes, roads, power lines, and entire neighborhoods. Low-lying coastal areas are especially vulnerable. In these regions, even a 1-meter rise in sea level can send water several kilometers inland. Add heavy rainfall and overflowing rivers, and the city becomes a basin, filling from all sides. For coastal communities, storm surges are not rare events. They are increasing in frequency and intensity due to rising global temperatures and higher sea levels. Each degree of ocean warming adds more energy to storms, and more energy means stronger winds, higher waves, and greater surges. It started like many storms, with dark clouds and steady rain. Residents followed updates from the National Weather Service. The system was expected to pass offshore. But by midnight, the storm had shifted course. The city, sitting on a shallow coastal plain, was now directly in the path. At dawn, winds began to pick up. By mid-morning, the first waves of water reached the harbor walls. Boats tore from their moorings. Seawater poured over concrete barriers. Within minutes, entire blocks near the shoreline were underwater. Downtown streets became channels. Buses and cars were stranded. Emergency services moved to higher ground, using inflatable boats to rescue families trapped in apartment buildings. Power substations failed one by one, plunging neighborhoods into darkness. The water rose steadily, first ankle deep, then knee-high, then waist-deep. By noon, the storm surge peaked. Tides combined with the storm's pressure to lift the ocean more than 3 meters above normal. Storm drains reversed, pushing water back into the city instead of carrying it away. Basements flooded instantly. Public transit tunnels filled like reservoirs. The sound was haunting, wind howling through empty streets, alarms echoing from submerged cars, waves slapping against storefront glass. In aerial footage, rooftops and treetops were the only things visible in some districts. From above, the city looked like an island archipelago. When the winds finally weakened, the water remained. It lingered for hours, sometimes days, before slowly receding. Mud, debris, and saltwater residue covered everything. The aftermath revealed the scale of the damage. Power grids offline, bridges eroded, thousands of homes uninhabitable. But behind the destruction lay a deeper story, one about human adaptation and the cost of living so close to the sea. Storm surges are not random disasters. They follow predictable physics, and that means their impact can be reduced if cities plan for them. Urban planners now use advanced models to predict how far inland surge waters can reach. These models combine satellite data, tide measurements, and local topography to simulate potential flood zones. The results help guide building codes and evacuation plans. However, preparation often competes with economic priorities. Many coastal cities continue to expand near shorelines because the land is valuable. Ports, resorts, and business districts rely on proximity to the sea. But this same proximity increases exposure to risk. Scientists from the Intergovernmental Panel on Climate Change, IPCC, warned that as global temperatures rise, sea levels will continue to climb. Even a 30-centimeter rise in average sea level can double the reach of a major storm surge. For many coastal megacities, from Miami to Manila, this means that future floods will be deeper, faster, and harder to recover from. Infrastructure built decades ago was not designed for these new realities. Concrete seawalls crack under repeated stress, drainage systems overflow, and older neighborhoods lack the elevation or protection modern engineering can provide. But it's not only about structures. Storm surges disrupt critical systems: power, water, healthcare, and transportation. Hospitals can lose electricity. Water supplies can be contaminated with salt. Roads used for rescue and supply can vanish beneath the tide. Some cities have begun to act. The Netherlands, for example, has invested heavily in adaptive flood defenses, movable barriers, floating neighborhoods, and advanced pump systems. In Japan, seawalls and multi-layered evacuation plans protect coastal regions from typhoon surges. In the United States, communities in Louisiana and Florida are testing artificial wetlands and elevated housing as natural buffers. These measures don't eliminate risk, but they buy time. And in a world of stronger storms, time means survival. When the water finally drains and the roads dry, the memory of the surge remains. The ocean is both life giver and destroyer. Calm one day, unstoppable the next. Storm surge, cities submerged is not just about one event. It's about a global pattern. Cities built where water once flowed freely. It's about the limits of our engineering and our ongoing challenge to adapt to a changing planet. The next storm will come, perhaps next year, perhaps next decade. But what happens then will depend on the lessons learned today. Because every storm carries the same question. How do we live safely with the sea that sustains us?